The wind outside is minus 50 degrees, cold enough to freeze bare skin in minutes. Snow is flying sideways so hard you cannot see your own hand in front of your face. Every breath feels like swallowing needles. And somehow, inside a small dome made of nothing but snow blocks, a family is sleeping warm enough to have bare feet outside their blankets. That is not a myth. That is a real igloo built by the Inuit people, doing exactly what it was built to do. Most people picture an igloo as a pile of snowballs stacked into a dome. A kid's snow fort, just rounder, something cute, something simple. Maybe even something a little silly, like a shelter you would never actually trust your own life to. But here is the truth almost nobody tells you. The igloo is one of the smartest buildings ever made by human hands. It is shaped using the exact same hidden math that keeps giant stone cathedrals from crumbling under their own weight. And we will show you exactly why that matters in a few minutes. It gets stronger every single night a family sleeps inside it, quietly turning soft snow into something closer to armor. And it can turn a tiny oil lamp, no bigger than a coffee cup, into enough heat to create a 70-degree difference between the inside and the freezing world outside. The Inuit had no computers, no steel rulers, no engineering degrees. They built all of this using a knife carved from bone or antler, and knowledge passed down from parent to child for thousands of years, generation after generation, out on some of the harshest land on the entire planet. It worked so well that scientists today study the exact same building tricks when they design shelters for Antarctica, and even for future space colonies on the Moon and Mars. So how did a house made of frozen water keep people alive through some of the coldest air on planet Earth? What did the Inuit understand about snow and cold and shape that we have almost completely forgotten? Let's step inside and find out. Chapter 1. The shelter that builds its own armor. Here is something that sounds impossible. The igloo does not stay the same every night. It actually gets stronger while people sleep inside it. Snow that starts out soft slowly turns into something closer to armor. And the strange part is, the people inside are the ones who make that happen, just by staying warm and breathing. Let's slow down and see how. When a family lights their small oil lamp, or when their own body heat fills the little room, warm air rises up toward the ceiling, the way warm air always does. That warm air touches the inside of the snow walls, and a very thin layer of that snow starts to melt. Not a lot. Just a tiny film of water, so small you might not even notice it happening if you were standing right there. That melted water does not just drip away, though. It soaks sideways into the snow around it, kind of like water soaking into a sponge sitting on a counter. Scientists call this capillary action, but you do not need the big word to picture it. Just think of thousands of tiny straws packed inside the snow, pulling that water inward and spreading it evenly through the block. Now here is the important part. Outside the igloo, the air might be minus 40 or minus 50 degrees. That freezing air is constantly pulling heat back out through the wall, second after second, all night long. So the thin layer of water that just melted does not stay water for long. It freezes again, and this time it freezes into something different than snow. It freezes into solid ice. Snow and ice are not the same thing, even though they are made of the same stuff. Snow is soft and full of tiny air pockets, almost like a cloud you could hold in your hand. Ice is hard, heavy, and solid. It does not crumble the way loose snow does, and it does not blow away in the wind. So this happens again and again, night after night, all winter long. Warm air melts a tiny bit of snow. Cold air freezes it right back into ice. Melt Freeze, melt, freeze. Slowly, the inside of the igloo grows a shell of hard ice layered right over the original snow blocks. Like a second skin, the dome quietly builds for itself while everyone is asleep. This process is called glaciation, and it means the igloo is doing the exact opposite of what you might expect. A pile of loose snow should slowly fall apart, day by day, especially with people breathing warm air onto it constantly. Instead, it quietly builds its own armor, one freezing night at a time, powered by nothing but the warmth of the very people it is protecting. Think about how unusual that really is. A cloth tent does not get stronger the longer you sleep in it. If anything, a tent gets weaker over time, worn down by wind and cold. A wooden cabin does not grow thicker walls just because a family lives inside it, year after year. But an igloo does exactly that. And once it has gone through enough of these melt and freeze cycles, that ice shell becomes strong enough to hold real, serious weight. Strong enough that a full-grown adult can stand right on top of the dome without it caving in beneath them. Arctic explorers have written accounts of animals pressing and pushing against igloo roofs from the outside, testing them with real force, trying to get through, and the roofs holding firm against all of it. That is not luck. That is not an accident of nature. That is a building method smart enough to use the very warmth that could melt it as the exact tool that makes it strong instead. But the armor is only one part of the secret. The real genius, the part that would make ancient architects jealous even today, is hiding in the actual shape of the dome. And that shape is where things get really interesting. Chapter 2. It's not a dome. It's forbidden geometry. Picture a hemisphere. Half of a ball, like half of an orange sitting flat side down on a table. That is what most people imagine when they picture an igloo. Round on top, flat on the bottom, evenly curved all the way around in every direction. Here is the twist. If Inuit builders had actually built true hemispheres out of snow, those igloos would have collapsed, probably within the very first storm. That sounds strange, but it comes down to something builders call ring tension. In a true hemisphere, the weight pressing down does not just push straight down through the walls the way you might assume. It also pushes outward, especially near the bottom third of the dome. Like the whole shape is trying to squash flat and spread out sideways under its own weight. Snow blocks are decent at handling weight that pushes straight down on them, but they are almost useless at resisting a sideways pulling force trying to rip them apart. So a true hemisphere made of snow blocks would slowly bulge outward at the base, crack, and then collapse in on itself. The Inuit did not build true hemispheres. They built something smarter, and they did it without ever writing down a single equation or drawing a single blueprint. Picture a heavy chain hanging loosely between two hands, sagging naturally into a soft U shape in the middle. That drooping curve has a name. It is called a catenary. Now picture flipping that exact curve upside down, like turning that U into an arch. Something amazing happens to the forces running through it. Every bit of weight travels smoothly down through the curve as pure squeezing force, with almost no sideways push at all, anywhere along the shape. That upside-down catenary curve, spun all the way around in a full circle, is the actual shape of a traditional igloo dome. Not a hemisphere, a catenary dome, built entirely by feel. This is the exact same shape that shows up centuries later in some of the most famous stone cathedrals and archways ever built by professional architects, using rulers, formal math, and years of formal training. Builders far from the Arctic eventually discovered on paper, using careful calculations, that this curve was the strongest possible shape for turning weight into pure compression. Inuit builders had already been using it for generations before that. Shaped entirely by hand, tested by feel, and passed down as pure inherited knowledge with no written math behind it at all, ever. So next time someone pictures an igloo as a simple snow dome, remember this. It is closer to a piece of hidden architecture, built using a structural principle so effective that it still shows up in some of humanity's most impressive buildings today, thousands of miles from the Arctic Circle. And once you understand the shape, the next question is obvious. Just how strong does that shape actually make the igloo? The answer involves real numbers, and they are more impressive than almost anyone expects. Chapter 3. The math that shouldn't work, but does. Let's talk numbers for a moment, because this is where the igloo goes from impressive to almost unbelievable. Engineers can calculate exactly how much squeezing force or compression is pushing down through the base of a snow dome. For a normal-sized igloo, built from properly wind-packed snow, that force at the base works out to roughly 56 grams of pressure on every square centimeter of wall, which is barely more than the weight of a few coins. Now compare that to how much force wind-packed snow can actually survive before it crushes and fails completely. That number is close to 12,000 grams per square centimeter, more than 200 times higher. Sit with that gap for a second. The actual pressure squeezing the walls of a real igloo is more than 200 times smaller than the amount of pressure it would take to crush those same walls flat. Engineers call that gap a safety factor, and a safety factor that large is not something you stumble into by accident. It is the kind of number you would expect from a carefully calculated modern building inspected by a team of professionals, not a shelter shaped entirely by hand, by feel, using nothing but a blade carved from bone. This is not folklore. This is not exaggeration passed down through storytelling around a fire. It is real structural math, and it proves something important. The catenary shape from the last chapter is not just a clever idea that happens to work most of the time. It is dramatically, measurably over-engineered for strength on purpose by people with no calculators, no blueprints, and no formal schooling in architecture whatsoever. Think about everything that had to line up perfectly for this to work, every single time, in brutal cold, often in fading light. The builder had to find snow packed to just the right density by the wind, which meant testing drift after drift by hand. Some builders would push a long probe into the snow, feeling for smooth, even resistance the entire way down, a sign the snow was packed just right below the surface. Others would simply step onto a drift with their full weight, checking whether their heel left a clean, crisp print without crumbling through into soft powder underneath. Only the right snow would do. Too soft, and the blocks would crumble apart in your hands. Too hard, and it would shatter like glass instead of cutting clean. Once the right snow was found, the builder had to cut blocks to a fairly consistent size using nothing but a hand tool, working quickly before fingers went numb. They had to lean each block inward at just the right angle as they worked their way around and upward in a single rising spiral, never stopping to measure with a tool, only trusting years of practiced instinct. And they had to do all of it from memory and feel, using knowledge taught to them by someone older, who had learned it the exact same way, from someone older still. No blueprints, no steel tape measures, no structural software double-checking the math after the fact. Just generations of trial and error, refined over and over across centuries, until the final design was, quite literally, hundreds of times stronger than it needed to be just to survive a single brutal night on the ice. That is not primitive building, no matter how simple it might look from the outside. That is precision, earned the hard way, passed down carefully over a very long time. But strength alone does not keep a family alive on a night when the outside world is 50 degrees below freezing. A wall that will not collapse still has to somehow keep a human body from freezing solid inside it. And that is where the igloo's next trick comes in. Chapter 4. The 70-Degree Miracle. Imagine stepping outside on the coldest night of the year where you live, the kind of night that makes your face hurt the moment you walk out the door. Now imagine that same cold, but 50 degrees below zero instead. Air that cold can start to hurt exposed skin in minutes, sometimes less. It is the kind of cold that stops car engines from starting, freezes eyelashes together, and turns steam from a cup of hot tea into fog before it even reaches your mouth. Now imagine walking into a small snow dome, ducking through a low entrance, sealing it behind you, and within a short while feeling warm enough to take off your heavy mittens. That is not exaggeration. In a properly built and lived-in igloo, the difference between the inside temperature and the outside temperature can reach as much as 70 degrees Celsius. Outside might be -50. Inside, with the right conditions, the air near the sleeping platform can actually creep above freezing, sometimes reaching well into comfortable double digits, warm enough to sit around in a light layer of clothing. Where does all of that heat come from? Not from some hidden furnace buried underground, and not from any kind of fuel-burning stove. It comes from two surprisingly small sources working together, quietly, all night long. The first source is a quillic, a small stone lamp carved from soapstone that burns oil rendered from seal or whale fat, using a twist of dried moss as a wick instead of string. A single one of these lamps produces roughly the same amount of heat as a small space heater, somewhere between 500 and 1,000 watts. That is less power than a hairdryer running on its highest setting, yet it is enough, on its own, to warm an entire enclosed dome through the night. The second source is even simpler, and it costs nothing at all. It is the people themselves. A resting human body gives off around 80 to 100 watts of heat continuously, all day and all night, without even trying, just from being alive. Put 2 or 3 people together inside a small, well-sealed dome, and their combined body heat alone can provide a real, measurable chunk of the total warmth, keeping everyone alive through the darkest hours before dawn. None of this would work, though, without the shape and the walls doing their job first. Remember the catenary dome from Chapter 2 and the self-building ice armor from Chapter 1. Together, they trap that heat instead of letting it leak away uselessly into the freezing air outside. The lamp and the people provide the warmth. The dome's shape and its layers of packed snow lock that warmth inside, the same way a thermos keeps a hot drink warm for hours after you fill it. It is a small amount of heat, from a lamp the size of a coffee cup and a few sleeping bodies, working inside a nearly perfect container. And that combination alone is powerful enough to turn one of the coldest places on the entire planet into somewhere a family could sleep safely, night after night, all winter long. But heat rising and staying trapped up high creates a new problem that any real shelter would eventually have to solve. What happens to all the freezing air pooling down near the floor, right where people have to walk in and out every single day? The Inuit had an answer for that too, and it did not require a single moving part. Chapter 5. Cold doesn't get in, it gets trapped below you. Here is a simple fact about air that most people never really stop to think about. Cold air is heavier than warm air. It sinks quietly, without any effort at all. Warm air is lighter, so it naturally rises and floats up toward the ceiling of any room it is in. The Inuit did not just happen to know this fact by accident. They built their entire entrance around it, on purpose as a working part of the shelter itself. Instead of a simple doorway cut straight into the side of the dome, many igloos were built with a long, low entrance tunnel that dipped down below the level of the main living floor before rising back up into the dome itself. Anyone entering the igloo had to crouch down low, crawl through this sunken tunnel on hands and knees, and then climb back up a short rise into the warm living space waiting above. That dip in the tunnel is not an accident, and it is not just there to block the wind, although it does that too. It is a cold trap built directly into the architecture. When freezing air pushes in through the entrance from outside, it is heavy, so it naturally sinks straight down into that low tunnel instead of spreading out into the living area above. It pools there, in the coldest, lowest part of the entire structure, far below where anyone is sitting or sleeping. Meanwhile, the warm air produced by the lamp and by people's bodies keeps rising the whole time, filling the upper part of the dome, right where the raised sleeping platform sits waiting. That sleeping platform is not just a comfortable perch chosen for convenience. It is deliberately built higher than the entrance floor, so that people spend their time resting directly inside the warmest layer of air in the entire structure, while the coldest, heaviest air stays trapped safely below them, down in the tunnel, the whole night through. Think about how efficient that really is. There are no fans anywhere in the design, no pumps, no moving parts of any kind, and nothing that ever needs fuel, batteries, or repair. Just the basic, unchanging fact that cold air sinks and warm air rises, used on purpose to design a shelter that manages its own temperature layers automatically, every single hour of every single day, without anyone having to think about it twice. It is one more example of the same pattern showing up again and again throughout the igloo. A quiet, elegant solution to a deadly problem, built from nothing but a deep, patient understanding of how the natural world actually behaves, tested across countless winters until it was perfected. Put all 5 of these ideas together, and the full picture finally comes into focus. A dome that grows its own armor while you sleep, turning soft snow into hard ice. A shape borrowed from the same hidden math later discovered in cathedrals half a world away. A safety margin more than 200 times stronger than it ever needed to be. A tiny lamp and a few sleeping bodies producing enough heat to beat the outside cold by a full 70 degrees. And an entrance built to trap freezing air below your feet, using nothing but simple physics and 0 moving parts. None of it came from a university lecture hall. None of it came from a textbook, a classroom, or a research lab. It came from thousands of years of watching, testing, failing, and trying again, out on some of the harshest, most unforgiving land on the entire planet, passed down carefully from parent to child, generation after generation, until it became something close to perfect. The next time someone pictures an igloo as nothing more than a simple pile of snowballs, you will know the real truth hiding underneath that soft, white surface. It might just be one of the smartest buildings human beings have ever made,